So in this exercise, we're going to continue on with integration by parts. Just to recap, if this is the first time you're seeing these set of videos, integration by parts is when we construct an integral in as a component of two terms, u and dv, and to get the solution, we calculate u times v minus the integral of v du, where v du is a sort of reconstruction uh, of the problem it's essentially a rearrangement, hopefully being a simpler integral to solve. Okay. Now, an important rule actually going through all of these presentations is the thing called the Lipit rule. I'll just go back up here a second, just scroll down too quickly. The Lipit rule is like essentially what we have to do, go back here actually again to go up further, is UDV. So you'll see this shortly that you have to determine which is going to be U and which is going to be DV. So there's a sort of order of precedence. Logarithmic terms come first, then inverse terms. For example, let's just see here. Let's get my pen going here. Something like cos to the minus 1 of x. Polynomials such as x squared, x cubed. Exponentials e to the x, e to the 2x, something funny with my pen, and trigonometric terms like cos of x, okay? So that's the order of precedence. Logarithmic terms would be first precedence to be u. Okay, so let's evaluate this. X squared log of x dx. Okay, let's evaluate that. So according to the Lipit rule, this is logarithmic. Well, this is a polynomial. Okay, so u is going to be log of x. Get the derivative of that. It's 1 over x. And just get an expression for du on its own. That is 1 over x times d of x. Okay, dv in this situation is going to be x squared dx. Okay, so just to sort of be clear about something here, this part here is u, so this part here and this part here has to be dv. Now to find what v is the integral of dv, and that's the integral of x squared dx. Okay, that's x cubed over 3. We don't have to worry about the coefficients, the undetermined coefficients just yet. We put them in at the end, and we're not at the end yet. So what do we do here? The integral I equals uv minus v du. Okay, so that is u is log of x, v is x cubed over 3. Let's just put that all over 3, minus the integral of v, x cubed over 3, times du, which is 1 over x dx. Okay, so what we're going to do is just tidy that up a bit. Traditionally, we put the x cubed term here first, and then log of x. It's just people are sort of used to it that way. The other way, leaving it alone doesn't matter, isn't against the rules either. X cubed divided by x, that gives us x squared. Okay, and we can take that cube 1/3 term out, so minus 1/3 x squared dx. Okay, x squared dx, the integral of that is fairly straightforward. That's x cubed over 3. So that the answer is x cubed log of x over 3 minus 1/3 times x cubed over 3. We can put that 1/3 and x cubed over 3. We can simplify that into one single expression. Just get rid of that, the 1/3 there, and put a 9 there instead. Okay, and then plus c, because we are actually at the end here. So the answer is x cubed times the log of x over 3 minus x cubed over 9 plus c. Okay, that one's grand. So one more. This one here, x times cos of 2x dx. Okay. Now, here what we have is a polynomial, and this part here is trigonometric. So we're going to let u equals x du dx is equal to 1, and therefore du is equal to dx. Now, the reason we have cos 2x here is as follows. So phi is the integral of cos 2x dx, okay, and that is sine of 2x over 2 dx, okay. So, yeah. Now, the thing about that is just watch out for is when you're dealing with polynomials like that, it's don't, for example, the integral of cos of ax, the integral of that it will have the form cos or sine of ax over a. That's just a sort of general rule, okay? How do you find that out actually? How do you prove that? You can prove that using the substitution rule. Okay, so there we go. Let's put that all together. So u, sorry, I just put in something here I shouldn't have. Just leave that out. That doesn't need to be there. Also get rid of that. Now, so u, the integral we're looking for, u v minus integral of v du. Well, u is equal to x. V is equal to sine of 2x over 2. And the integral of sine of 2x over 2 dx. Okay, du is equal to dx. Okay, so this part here, that's v, and this part here is du. Okay, so let's get them all together now. Oops. What's going on there? Sorry, just go back here a second. I pressed something I shouldn't have. I'll just keep going. Okay, just nearly finished this anyway. So what we have to do here is integrate sine of 2x over 2. What we could do is simplify that integral. So x over sine 2x over 2 minus 1/2 sine of 2x dx. Sine of 2x, the integral of that is minus cos x, or minus cos 2x over 2. More to the point. So that is equal to x sine of 2x over 2 minus 1/2 times minus cos 2x over 2. Okay, we can simplify that. We have two minuses there, so they just cancel out into a plus. And we have 1/2 times 1/2, so that's something over 4. So sine of 2x over 2 plus cos of 2x over 4, and then we put in our integral, our integration constant, our unknown integration constant there at the end, plus c. So that's a wrap. We'll leave it there.